Hello, and welcome to another episode of Yummy Data Science. In this series of videos, we are continuing our discussion on DPLYR. And for the sake of context, this is for my class at UMass Public Health Data Science. So, in the previous video, we talked about the verbs of DPLYR. There are four major groups depending on what they operate on. So, for example, rows, a filter is an example of a filter is a verb that operates on rows. Mutate is an example of a verb that operates on columns. And their groups, we talked about by group and then the summarize. And in this video, we're going to be talking about the tables set of verbs. And when we are working with tables, that means, we have more than one table. So far, we've just had one table. That means to join or combine data. And combining can be done in two ways. So you can think about a same data set that you have with the same exact number of columns, but you have 10 data sets. Each one is for a different year. And say you want to make a master data set, you probably want to stack them. So say you have two data sets, you want to stack them one on top of each other. And we call that combining data vertically. And the way you do this in R is with the C underscore bind. So you're binding the columns. Think about it as these are my two floating data sets in space. And now I'm binding it. I'm tying them up with a string around. So that's what it's doing. Now, C-bind is not the focus of today's lecture. Today's lecture, we're going to be talking about join. So now we have two data sets, and now my fingers are going to serve as rows, and they're going to join with the data set. So in here, I've got 5 fingers on this, so I've got 5 rows. I've got 5 rows here, and they're going to join perfectly. That's like a perfect join. But we're going to talk about joins where the rows don't match up. So let's talk about it conceptually first. And what I really liked was the textbook, R for Data Science, with Hadley Wickham and his co-authors. He does a really nice job. So I thought, why not just take his material and show you how he does it? So he has created two data sets, X and Y. And X has 3 observations, 1, 2, 3. And the 1, 2, 3 is an ID. You're going to join it. It's a key. And this is the value. So this is the column that is being represented. And in here, you can see by color, with the color, that green will go with green. So these two will match up. The purple will go with purple, but then the orange and the yellow won't go because this is 3 and this is 4. So he's done a really nice job. So given two tables, X and Y, what does an inner join mean? An inner join would mean that you put these tables and then you get, as you probably guessed it, the green row, the value of 1 and the value of 2. And then you get x1, x2, the column from X, and then you get the column from Y. So that's an inner join. Now, the most common join that there is the left join, because you're generally taking a driver table and then you're looking things up in another smaller table. You're looking up descriptions, codes, etc. So here, X's are left. So that means we're going to be keeping all the rows in X, 1, 2, 3. But 3 is not going to match up with anything in Y. So it's just going to put NA here because the val y doesn't exist. So we put NA, and that's what a left join is. Right join, it says the same thing. It's the order is flipped. So you can do a right join by doing a left join with the flipped order. But if this is too confusing, don't worry about everything and you can just ignore the right join. But in this case, you right join X and Y. So now we're going to keep all the observations that are in Y. So 1, 2, 4, and the val X is going to be NA. And there's a lot more on joining. R for data science, the textbook does a really good job trying to explain what equality joins are and joins based on inequality, fuzzy conditions, anti-joins. So let me just show you a little flavor of what this would look like in R. So what I've done now is, as usual, I have opened up my public health class project file, and then I've opened up the script, which is module 4, the second script in DPLYR. And I've copied and pasted the code from the textbook because it seemed like it was a really, really useful and good summary. So why not reuse it? So I'm taking this, and you can see the syntax here. I'm actually creating a triple. So that's it. That's a way to create your own data through your program. So if I run this, I'll see that I have data X and I have data Y. And the key and the val X are columns in X. The key and the val Y are columns in Y. And the first thing I'm going to do is an inner join. And you will see that the data will be very much what I showed you. So this is rows 1 and 2. Then here we expect rows 1, 2, and 3 because it's a left join. And here we expect rows 1 to 4. And here full join means take the rows in each, it's an or. So either rows in X or rows in Y. So we'll now have rows 1, 2, 3, and 4. So you can see that's what's happening. And now anti-join is pretty interesting. So I just wanted to show you because I use it a lot in my work, is show me the rows that do not join with Y. Okay, show me the rows in X that do not join in Y. And that would be 3. So that's the only one. And here we go. And this concludes a short video on the table work, and we talked about joins in DPLYR. Thank you for listening.